Facts Only Test Prep.
Welcome to Facts Only Test Prep. We're called Facts Only because we give you everything you need and nothing you don't when it comes to the SAT. So please enjoy the next video.
30, 60, 90 triangles.
The geometry on the SAT feels either really easy or really difficult to students. I think when it's easy, you're using basic area formulas. You're given length and width or height and base, and then you're being asked to find the area, or you're working backwards and trying to find one of those dimensions. But in the later portions of the math section, a lot of the time you're being asked to use more than one skill at once, or to do compound calculations in some other way, and that can really frustrate students. When those questions arise, it really helps to have an indicator, and this lesson is all about using the indicator root 3 to tell ourselves that we are looking for 30, 60, 90 triangles. These don't show up all the time, but when they do, they show up late, and they allow us to get points that we otherwise couldn't get, and we can squeeze the last 10 or 20 points out of a test and really get that score that we need. So for today's lesson, you're going to need Test 2, Section 4, Question 30, and Test 2, Section 3, Question 19. Pause the video, go to factsonlytestprep.com to click on those links if you need them. And let's get a look at Test 2, Section 4, Question 30 to start. It says, the figure above shows a regular hexagon with sides of length A and a square with sides of length A. So every straight line in this figure has the same length. That's helpful. If the area of the hexagon is 384 root 3, now there's that root 3, square inches. What is the area in square inches of the square? The reason root 3 is so helpful is it tells us that we're dealing with a 30, 60, 90 right triangle. That's the only reason the test writers make this a part of the SAT, is to see if you will identify it as such. So when you see root 3, either as part of the description of a question or as one of the answer choices, you should be thinking about making one of these right here, or about finding a hidden one. One of a 30, 60, 90 won't show up in the square. A square can be made into two 45, 45, 90 triangles, but not into 30, 60, 90 triangles. So the 30, 60, 90s will be showing up in this regular hexagon. And I'm gonna move over a screen to where I've already cut the hexagon into 6 equilateral triangles. And then I wanted to show you that an equilateral triangle can be made into two 30, 60, 90 triangles. That feels like a lot to know. So here's what you maybe want to keep in mind. Hexagons can be made into equilateral triangles, and equilateral triangles can be made into 30, 60, 90s. That is sort of skill specific to the SAT. So if you think you're looking at a hexagon, probably means they want you to turn that into 30, 60, 90s. Here's what we know. The area of the hexagon is 384 root 3. We also know that this hexagon can be made into 1, 2, 3, 4, 5, 6 equilateral triangles, or into 12 30, 60, 90s. I'm not going to draw them all because we've got some technological limitations here and some handwriting limitations, to be honest. But you can think of this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 10, 11, 12 30, 60, 90 triangles. The reason this is helpful is, going back to our diagram, 30, 60, 90 triangles have this proportion: x root 3, 2x. The short side is always the x dimension, the middle side is always the x root 3 dimension, and the longer side, the hypotenuse, is always the 2x dimension. That is the relation of one side to the other. So even though we don't know the lengths of these sides, let's just take one of these. We know that there are 12 of them. We don't know the length and width. We can say that this is the x side of the triangle, and that this is the x root 3 side of the triangle. Now that we have that information, we could say that the area of one 30, 60, 90 is, and we know the area is base times height times 1/2, is x times x root 3 times 1/2. Now we're operating in one variable instead of the two variables of base and height. Here's the other good news. We have the area of the entire figure. The entire figure is 384 root 3. And because there are 12 30, 60, 90 triangles, we can say that 384 root 3 equals 12 times x root 3 times 1/2. The first thing I want to do, I'm going to switch to another color just to give us some separation. I'm going to clean up the algebra on the right-hand side. So I think that we can rewrite this as 384 root 3 equals 12 times 1/2 is 6, and x times x is x squared, and root 3 is still root 3. So we have 384 root 3 equals 6x squared root 3. Now the algebra is going to get pretty easy pretty quickly. The root 3's cancel. I'm going to divide both sides by 6. And now I'm going to get that 64 equals x squared. This is the calculator part of the SAT, so if this information doesn't come as quickly to you as it's coming to me, partially because this is the 7th take that we've done of this video, but partially because I can do that division. You'll have a calculator to help you. 64 equals x squared, so now I'll take the square root of each of these, and x equals 8. If x equals 8, and that's 1/2 of this side, then that means that the whole side and all of these sides equal 16. That includes this side of the square is 16. And to find the area of the square, we just need to take 16, let me draw that 2 a little better, to the second power, and 16 to the second power is 256. I know that's a lot. Here's how you can not only get better at this, but master it. Do this specific question 3 or 4 times or more. Time yourself each time. Watch how much faster you become after the second or third time you do it. And do this until you can execute all of the steps in under 75 seconds. If you can do that, then the next time you spot a 30, 60, 90 triangle question like this on the SAT, you'll have no trouble with it. Also remember, this is the hardest one of these that anybody has seen. Anything that you see beyond this will be as difficult or easier. So don't be thrown by what we're doing here today. Moving forward, this is test 2, section 3, number 19. We've got radians, we've got a circle. Some of you might want to solve this with a unit circle. Feel free to do that, not a big deal. If you're totally lost though, look at this. Well, let's read it. In the XY plane above, O is the center of the circle, not 0. And the measure of angle AOB is pi over a radians. What is the value of A? You might feel completely lost, but look at the coordinates of point A, root 3, 1. This should be an indicator that you should be making a 30, 60, 90 triangle, which isn't insane because if you have studied the unit circle, you know that 30, 60, 90 triangles are one of the pillars of the unit circle. That's a discussion for another time. If we draw a triangle from point A to the x-axis, we make a right triangle. And hey, because the x-coordinate of point A is root 3, we can tell ourselves that this particular length is let's go back, I'm going to do that with an arrow, is root 3. We also know that the height of this triangle is 1. Hey, let's look at our proportions now. We have a 1, we have a 3. Remember that a 30, 60, 90 triangle has proportions x, x root 3, and 2x. In this case, we're dealing with 1 times root 3, which is root 3, and 2 times 1, which is 2. So that would be 2. That part actually doesn't even matter. What's most important is we now know that this is a 30, 60, 90 triangle, and these measurements are 60 degrees, 30 degrees, and 90 degrees. I know it's a little bit sloppy on the triangle there. That's at the beginning of each math lesson. Again, here's our magic triangle. And they give that to you at the beginning of each test. You don't need to memorize it. You just need to recognize it. So we know that this is 30 degrees. It's the small angle on a 30, 60, 90 triangle. Our last step, and because this is a number 19, they always add something extra, we need to convert 30 degrees to radians. So what we can say is that 30 degrees of an entire circle, 30 degrees of 360 degrees, is the same as some number of radians, we'll just call it x, over, and the number of radians in a full circle is 2 pi. I'm just going to go back to that front page again to show you something. That information is given to you on the second line of the same page as you're given the special triangles. The number of radians of arc in a circle is 2 pi. So 360 degrees equals 2 pi radians. So we can say that 30 over 360 is equal to x over 2 pi. Now we're just doing algebra. I'm going to cross multiply so that we can say that 360x equals, let's see, 30 times 2 pi is 60 pi. I'm going to divide both sides by 360. And x, I should put an equal sign. I'm going to put an equal sign between these guys now. There we go. 360x is equal to 60 pi. Divide both sides by 360. And x equals 60 pi over 360, which can be simplified to pi over 6. The question is asking us for the value of a, and they're saying that the measure of angle AOB is pi over a. And this is simple, just term recognition, that if pi over a equals pi over 6, then a equals 6. And that's what you would bubble in because this is a free response question. Again, I know that each of these questions is involved. It involves a second and maybe even a third step. These are late questions. The two best things that you can do are, number one, get used to recognizing the cues like that root 3. And number two, practice these specific questions multiple times, because getting comfortable with those processes and then getting fast with them is the surest way to make sure that you get these points on the SAT itself. Good luck, everybody. Hey, thanks for watching, everybody. Make sure that you like us and subscribe and hit the notification bell. That way you'll get information on the new videos as soon as they're available. It helps us a lot. Also, visit us at factsonlytestprep.com. That's where you'll find links to the tests that I use in my lessons, along with some other resources that we prepared for you. Thanks and good luck.